Hi everyone. Today let's solve the problem number 875, Coco eating bananas, right? So what the question states here, we have been given n piles of bananas. So this is nothing but the n piles of bananas, 3, 6, 7, 11, these things, right? This is nothing but we have been given n piles of bananas. Here n is 3, 6, 7 and 11, right? So we have been given n piles of bananas. Each hour Coco eats k bananas from the pile of her choice. Means Coco will eat each her k bananas from her choice, whether it may be 2 within 3 here, whether it may be 4, or whether even it may be 6 completely, whether it may be 5, like that, right? So this one, each her Coco eats k bananas from a pile of her choice. If the pile has fewer than k, if the pile has fewer than k, then she eats all and waits for the next hour, and waits for the next hour. So whether k equals something 4, k equals 4, then she'll eat 3 and wait for the next hour, right? So if the pile has fewer than k, she eats all and waits for the next hour. Coco has h hours to finish all the bananas, right? So what we need to do here, we need to return the minimum integer k such that Coco can eat all the bananas within h hours. So we need to return minimum integer k. So we need to return the minimum integer k such that Coco can eat all the bananas with h hours within h hours, right? So we need to use the binary search to find the minimum k. So we need to use the binary search to find the minimum k. They have given straightly here that we need to use the binary search to find the minimum k here, right? I hope this part is completely clear. Question part is completely clear. So see here, we have the piles of bananas. This one 3, 6, 7, 11, and we have the hours 8, right? So here the minimum integer k such that the Coco can eat all the bananas within 8 hours is 4. Within 8 hours is 4, right? So I hope this part is clear. Let's come to the second example. Same thing. We have been given hours equals 5 here. In this case, the minimum integer k such that Coco can eat all the bananas in 5 hours is 30. 30, right? So within 5 hours. So same goes with the third example. So here answer is 23, right? 23. So I hope the question part is completely clear. Let's discuss the approach followed by the complexities, and then let's write the code, right? So here uh, the approach, let's consider the first example here. Let me come here, just give me a second here. Yeah. Let's consider the first example here, right? Just give me a second here. Yeah. Let's consider this first example here, right? Let's consider the first example. We have the piles of bananas 3, 6, 7, 11 here, h equals 8. So max bananas in any pile is 11. Max bananas in any pile is 11 because we have the highest pile of bananas that has been given here as 11 within the array, right? So max bananas in any pile is 11, right? So it starts from the minimum, it has to be 1, and the maximum is 11. So the range is from 1 to 11 here. The range is from 1 to 11 here. So let's try the binary search on k. Let's try the binary search on k here. Mid we have got 6. Mid we have got 6 here. 1 plus 11 by 2, nothing but 6 here, right? Mid equals low plus high by 2. Here in this case 1 plus 11 by 2. Range, we are going with the range, right? So this will be 12 by 2. In this case it will be 6. Mid will be 6. Perform let's go with the this one. Let's go with the pure binary search now, right? So this will be seal of 3 by 6. We are performing on all the numbers basically, right? So this will be 3 by 6 plus 6 by 6, 7 by 6, and 11 by 6 plus 11 by 6, right? So this will lead to basically the answer that we get here is 1 plus 1 plus 2 plus 2. Here in this case we get 6. 6, whether we check this is less than or equal to 8, because hours we have given here as 8. Less than or equal to 8 because the number of hours they have given here as 8, right? Yes, 6 is less than 8 here. So this one, this satisfy the condition. Next we will try with the smaller mid. Now we got the 6. Now we will half and we will go with the mid, right? So here in this case we'll get the mid element 3, mid 3. So every time we'll have using the binary search, right? So here on this case, so we will go with 3 by 3, 6 by 3, 7 by 3 and 11 by 3. The answer that we get here is 10, but 10 is greater than 8. The number of hearts they have given here is 8. So 10 is greater than 8 here. It miserably fails here. We cannot consider 10, right? So 6 we can consider. 6 we can consider. Now we will try k equals 4. Now we'll try k equals 4. We'll do the same thing. Now we'll try k equals 4. When k equals 4, we will go with 3 by 4 plus 6 by 4 here plus 7 by 4 and 11 by 4. We'll perform seal, right? We'll perform math, this one seal, right? So here the answer will be 8. The answer will be 8 basically, right? The answer will be 8. So this is also valid. This is also valid. So here in this case, the element that we got here, this one, the minimum integer k, such that the Coco can eat the all, so that Coco can eat all the bananas within HR says 4. Within HR says 4. Here this one also satisfy the condition basically. What we can consider this one 6 as well here in this case, right? So but what happens here is, this one we have to find the minimum integer k. 6 and 4 both satisfy the condition here, so we have to return the minimum integer k so that Coco can eat all the bananas within HRs. So minimum of 6 and 4 will do here. Math.min of 6 and 4, all the valid ones will do. So minimum will get here is 4. So we will return 4 here in this case. The output that we got here is, so this will lead to basically 8. 8 is less than or equal to 8, we'll check. So 8 is less than 8, right? Yeah, this one 8 is less than 8. So this condition satisfies. So k equals 4 also satisfies here. In this case, the answer that we got here is 4, which is equivalent to the output that they have given for the example 1. Right. So here the approach works absolutely correct for this case. The approach works absolutely correct on this case, right? I hope the approach part is completely clear. Right now, as we are completely familiar with the approach, let's quickly discuss the complexities. Let's quickly discuss the complexities, right? So what would be the time complexity here? So we are going with the binary search, right? So overall time complexity would be big O of n into logarithmic of max. So you can ask, why it is not big of logarithmic n. We are considering n into log max because we will be performing binary search over 1 comma max pile. Means here, for the first example we consider the range 1 comma 11 because 11 was the maximum, this one integer that we had in the array, nothing but the max pile that they have given in the particular array. In this particular array, example 1 is 11, so 1 to 11 we'll consider, right, for each k. So we can scan all the piles. So here in this case it will be big of n into log of logarithmic max. So this will be the time complexity, overall time complexity. What would be the space complexity here? The overall space complexity would be big of 1. So why it is big of 1 here? The space complexity here, why it is big of 1 here? Because we are not making, will not be making use of any extra space except the variables, right? So except some variables basically. So the time complexity would be big of n into logarithmic max, and the space complexity would be big of 1 for the code that we'll be writing in the future. Now, as we are completely familiar with the approach as well as the this one, what do we call, um, approach and complexities, we are good to write the code, right? First, minimum, we have to go with the minimum speed that the Coco can eat, right? So for that one, let's initialize left to 1. We'll be going with the left and right pointers here. So let me initialize the right to. So here, let's do one thing. Let's make use of the this one. What do we call, uh, get max? This one, get max function, another function, right? Helper function. So I'll just give here get max, get max of piles. So we have to get the maximum number of piles from the this one array, right? So here, uh, before writing the code within the main function, let's write the get max, this one. what do we call, helper function. So here I'll just go with get max method, basically Java, right? So here this will be get max of, this one will be int, so this one will be piles. This is fine. So within this method, first thing, so let me initialize this one to max equals 0, and let's go with the iteration part here. For let's consider individual pile of piles here. So this one, if pile is greater than max, then what we'll do, max equals, let's assign this one to the pile. So finally what we will do, will return max, will return max. This is how we calculate the max, right? So we are just calculating the maximum number from the this one piles array, that's it, that's they have given piles of the bananas, right? Here this one I'm speaking of, right? So I hope this part is completely clear. Now we can make use of the get max. We have successfully made use of the get max already. I have written, don't get confused here, right? So next what shall we do here, just give me a second here. So yeah, now we have to store the minimum valid k that has been found till now, right? So for that one, let me take the result variable or answer variable and assign this one to the right, right? So this is fine, this is easy. Now let's perform the pure binary search here. So let's go with while left less than or equal to right. The first step is calculating the mid, nothing but we have to try the mid as candidate k. Accordingly with the approach that we discussed, we have to try the mid as candidate k, right? So here in this case I'll just go with mid equals left plus right minus left, this one by 2. This is fine, this is fine. So next step, so we have to check whether Coco can eat all the piles, Coco can eat all the piles of bananas within the hearse or not. For that one, let's make use of another this one helper function, can eat all. Means we will be making use of the helper method here. So not the function, this is Java, right? I get confused a bit. So this one will be writing the helper method to check if Coco can finish all the bananas at the speed k in HR. So that's what they have given in the question. Basically we have to return the minimum this one k, min k, right? So here we'll be, again I'm telling, we'll be making use of the helper method to check if Coco can finish all the bananas at speed k in HR. So I'll just go with here, so helper method we are making use of, right? So this one here I have to, so this will be private boolean can eat all. So here this will be int, and this one will be piles basically, and another parameter is k here, and one more we need h, nothing but hearts, right? This is fine. So just give me a second, why another parenthesis here? So yeah, here by mistake I have given one more square bracket, not the parenthesis, sorry. This is not required, right? So this is fine. So within this method, first step is let's initialize the total hours to 0 initially. Then let's go with the iteration, let's move on with the iteration here, pile of piles, this is fine. So within the iteration what we'll do, we will be going with a formula, nothing but same as seal of pile by k. Here this one I'll just write this one calculation, total hours equals total hours plus pile plus k minus 1. Either you can go with this one k minus 1 by k, or you can just go with seal of pile by k, seal of pile by k, that also you can do, both are same here. So this is fine. The next step is we have to return the total hours, right? So we have to return the total hours which is less than or equal to which is less than or equal to h, which is less than or equal to h. We got 6 and 8, so basically we have to return the minimum k, right? So we went with 4 for the first example if you remember. So here in this case we have to return, sorry, yeah, we have to return total hours less than or equal to h. This is fine. I hope this part is completely clear. The final step here is we'll be making use of the can eat all method within the main function, within the main function. So here can eat all. What are the parameters that we need to pass here? Files, mm, mid we have, and h. So this is fine. Files mid we have and h. So here let's assign answer to mid. This is fine. And write to mid minus 1. This is also fine. Else what we will do? We will try the bigger k, means we have to move the left pointer. We have to move the left pointer to right. So here if answer equals mid, then we have to return the mid value. If it is not, then we will try with the smaller k, nothing but we will be moving the will be decrementing the right pointer. Left side means we'll be moving, will move left basically. Here in this case we'll move right, means we'll be moving the left pointer to right. So here we can write the code in this way: left equals mid plus 1. This I don't have to tell you, have to know the binary search pretty well. That's it here in this case. So the last step here is we have to return the answer. So this is it for the code. Let me format the code once and let me hit the run button. I hope the coding part is completely clear. So we have, yeah, here I have misspelled total hours, line number 37. So this one, let me correct this one. This is fine. Let me run the code again. So now you can clearly see sample test cases are getting passed. Means the code works absolutely correct. Let me hit the submit button quickly. So wrong answer we are getting. What is the wrong answer here? Expected 3, output 1, 125 out of 126 test cases passed. One test case is failing. So let's see what is wrong here. So what is wrong here? I don't get it. So this is fine. So let me make this one capital E. This is fine still. Mm, this shouldn't harm anything. So still, if I run this one, so still we are getting this error. So it is failing for the large numbers, right? Do we need to use long here? Just give me a second. I think we need to add long here. Let's try this one. Let's see whether this works or not. Basically here we are going with the int, right? So let's do one thing. Uh, let me let's convert this one to the long. This is failing for the large numbers, I think, in my opinion. Let's see. So let me run this one. Let's see whether this works or not. So this works. Let me hit the submit button. I hope this works, man. Let's see. Still we have the wrong answer. Long is not working here. So here, even though we are making use of the long here and the line number 34, this one I'm speaking of. So we are still storing this one in the integer, right? Integer. So this one, let's change this one to long as well. Let's see whether this works or not. Let me hit the submit button again. So yeah, now you can clearly see all the test cases are getting passed. So I have hit the submit button directly instead of the run. So this is working for all the test cases. Means whatever the code that we have written works absolutely correct. So this was the problem basically. So I should have made use of the long instead of the integer. So that was causing overflow for the large numbers, right? So this is fine now. So this code works absolutely correct in this case. The code works absolutely correct in this case, right? I hope whatever the code that we have written is completely clear. I hope the solution part is completely clear along with the approach and complexities, right? For now, this is it. Thanks for watching, guys.